Oh, welcome everybody. So my name's Amal and I've got Simon Igloi joining us today from Townsville City Council. He's kindly offered to talk about what they've done with the pressure monitoring in town there. So quick note on the agenda items today. Just go to the next one, Simon. So you're allowed to, you can ask questions during the webinar today. You don't have to wait till the end. I'll be monitoring them as Simon speaks with Siobhan. And we also have the next webinar we have coming up on Wednesday, the 7th of October. Siobhan will be speaking about how Taggle handles the customer communication side of things, which we've got a lot better at over the years. Cool, thanks, Simon. So today's webinar is about monitoring pressure. So you might have pressure issues in your network. You could have hilly terrain like some of our customers do, or flat terrain, predominantly flat terrain. And you might be in the process of planning pump station installs and things like that. You might be getting constant water main bursts caused by continually fluctuating water pressures. Some of our customers have had this. So by having a monitoring system in place, you can make educated decisions to solve the problems within your network with as much information as you can have. Thanks, Simon. So many of you have seen this image before if you've come to one of our webinars. We have our water meters here on the top left, chatting to our receivers, which then backhaul all the data to our various Aquila systems and portals so you can digest the data on your end. Today, Simon will be speaking about how he leveraged his existing Taggle receiver network, which Townsville originally deployed for water meter monitoring, to then start monitoring the pressure in Townsville's network, and what he's been able to do with this additional knowledge that he wasn't able to get before in a cost-effective manner. So I'll hand over to Simon from now, and I'll just be monitoring the questions. Thanks, Simon.
Excellent. Thanks, Amal. We'll go one up. So, look, welcome. I suppose first and foremost, thanks for spending a bit of time to listen to me yabber on about pressures, pressure sensing. We thought we'd first talk a little bit, just very briefly, about the coverage we've got in Townsville. So we've got, you can see there, where our receivers are located at the moment. It will be growing over the next couple of months by another 6 receivers, especially Maggie Island, as you can see over there, is pretty bare in terms of receivers, as well as a bit further south and north of the actual township. You can see from there where we do really need some more receivers. Look, it's basically, we've installed some meters on a bit of a whim. So these are all water meters, not pressure sensors. I'll come to the pressure sensor map in a second. Interesting to see that we actually get some really good reception from far away that we wouldn't have thought. But then there's also some of those little black spots, I suppose, in town where we should have reception, but something conspires against us. So here we go. This is a snapshot from the Aquila sewer visualization platform. So we've currently got about 83 pressure sensors installed. We're constantly kind of installing more as we go. Initially, we installed around about 70 around town, and pretty quickly found that the easiest way to install these is actually in parks and open spaces where we've got large irrigation systems and we have backflow preventers already. So in the RPZs, you generally find pressure test points that need to be tested every year or every 6 months, depends on your codes and your standards. And it's a really quick and simple installation. So these particular pressure sensors, they do just slot straight in. It's a 5-minute job, and you instantly get the pressures. One of the lessons learned there pretty early is make sure that your RPZ is in front of the any master valves. Otherwise, you're just getting pressure when the irrigation's on, which is not quite ideal. Hang on, Ian's only seeing the first slide. Is that everybody else's problem, or?
I can see the pressure sensor coverage page with the Aquila sewer map. Yeah.
Cool.
Yeah, I don't know. That's really strange.
I'll keep going. I'm not sure how I can fix that for you, Ian. Sorry.
Ian, maybe leave and then come back in, perhaps. Maybe it's back somehow.
I'll push on if that's all right.
Mhm.
Excellent. Hang on, just let me not move on. Here we go. So these are the sensors, the pressure sensors we're currently installing. Look, they're very, very robust. We have managed to break a couple. I wasn't around when it did happen, but I believe it's got something to do with over tightening. But they're very, very simple device to install. We've got them currently set at a 15-minute transmission interval for sort of battery saving, and that's getting us excellent information on the data, on the pressures in our network. Look, there's probably a discussion to have there if you want to have, in some instances, a 5-minute interval for some specific applications, if you have issues that you can't resolve with the 15-minute ones. I do have a couple of 5-minute LSTTs here that I've disconnected from the battery, so they're not transmitting. So I do use them on an ad hoc basis if I need some higher frequency pressure sensor data. Look, yeah, like I said, the sensors, we haven't had any issues with at all. They've been pretty robust. We have to say I've had a few being destroyed, sort of vandalism type of things. But look, that's the risk you go, and in the end, it's worth the data you're getting out of it. Now our first little case study with the beautiful picture there of Pallarenda. I don't know if you can you see my mouse here? Can you see the mouse cursor? Yeah, excellent. So this is the suburb of Pallarenda right here at the coast, right at the end of this little peninsula. And one of the main issues being here, if I go to the next slide, we can see here. So Pallarenda is fed by some reticulation mains that are coming off a bulk main that runs down the coast here and then actually heads over across the magnetic island undersea in an undersea pipe. This is governed by a large butterfly valve, which is sort of sitting around about here, and that's controlled by the water levels in the reservoir, in one of the reservoirs of Magnetic Island, meaning that this valve comes on, so it pops on and pops off as it needs to in regards to the water levels on the island. And the function of being fed off this big bulk main near this valve is that the water pressure dramatically changes quite quickly and quite substantially. So from an average pressure of around about 550 kPa, it can drop down to as low as 280 kPa at the instant the valve opens. Look, that's still not below our service standard, which is 220 kPa and 30 litres a minute. However, because of the almost, everybody's gotten used to that higher pressure, that big drop off really causes issues sometimes for people that have got their irrigation system set to specific pressures, or they have, some other high water use appliances they're using at home during those times. Now, going back over the years, we looked into this. There was many complaints for water pressure in Pallarenda, and when we came to the table, it was basically already agreed that we engage a consultant to have a look at our standard engineering solution. So we've got a problem, we'll fix it by putting some more infrastructure in, and basically it would be around about $4 million to separate Pallarenda from the current bulk main feeding Magnetic Island. We thought that's probably a little bit much. Hang on a second. That's probably a little, probably a little bit much in terms of just because of one valve and the pressure, those pressure drops. I thought maybe we can manage that a little bit better if we understand the problem better. Prior to this, we only ever went out and did on the spot pressure checks, as you do, so at the water meter, and obviously that's missing a whole lot of the picture because most of the time we would see that the pressure's fine, so we'll just ignore the issue. So we went in, this is some of the first pressure sensors we installed. We picked some trusted users, for want of a better word, a combination of, let's say, friends and ex-council staff, and installed these pressure sensors actually on the owner's side. Reason to be on the owner side, it's just a little bit easier sometimes with how the water meter is connected and the shut-off valves. You'll see there we're using the LSTT, but you can also, if you're an eagle-eyed observer, you can see we're actually running a T probe into that V100. Reason being, at that particular time, the reception Pallarenda wasn't great, so we actually used a high-powered tag to get the data from the water meter. Look, straight away, this is the first day of data we collected. This is a little while ago, and you can basically see the times here where this valve opens and shuts. Interestingly, we also saw some really interesting overpressure events. Now, originally, when I bought these pressure sensors, I was ensured that our pressure and our reticulation network would never go over 1,000 kPa. Well, it does. So I had to buy a different sensor. Originally, I bought a 0 to 10 bar or 0 to 1,000 kPa pressure sensor. So we, I guess, upgraded to a 0 to 16 bar or 1,600 kPa. So look, from this, we had a, where's my mouse cursor gone? Apologies. So from this, we kind of saw, look, that there's clearly an issue going on here in terms of how we're operating this valve. And without knowing too much about it, we started investigating some of the options that could go along. The good thing is, as with any kind of new technology, new sensor technology and data, everybody's always a little bit skeptical if it's actually accurate. But what we were able to do from the control valve data from SCADA was actually to validate those pressure drops perfectly with the operation of the valve. So we knew it was related to that valve. What we also saw is, though, that something we expected to happen didn't happen, and that is a significant pressure drop during watering times. At that stage, we were still in fairly severe water restrictions with only a watering window between 6 and 8 p.m. And we actually saw that wasn't as big a deal as we first thought, which was good in one way and a little bit sad in the other. But because it just meant we had to have a look at the we just had to look at all the different options, I suppose, what could impact the pressure. Sorry, I'm just trying to read the chat at the same time as well. And I'm just having a look at the installation on the customer side. It's easier. Look, basically, because we can turn off the stopcock at the meter, put that T-piece in, and when we're done with it, we can just turn the stopcock off there as well. So we don't have to find the service valve in the street, you know, potentially turning off 1 or 2 houses worth of water. So in the domestic field, we like to install them after the water meter. It does give us a little bit of interference with pressures sometimes. Obviously, you get those sort of, you know, now with the dual check valve water meters, you get a little bit of back and up pressure, bit of higher pressure readings sometimes. But what we're really looking at, obviously, is the overall trends. Hope that helps. Okay, so look, because of this data, we then also managed to look at, there's clearly an issue here. We want to have a look at it a little bit closer. Let's hold off on spending the $4 million on decoupling the suburb while we investigate a bit further. In the meantime, we've actually upgraded the telemetry system for the valve, so we can change the times that it's operating remotely rather than manually, which was always a little bit of an issue. And we're looking at now is actually putting a new actuator onto that valve that'll allow us to slow the opening and closing times, but also have a partial opening if we needed to. So what we'll do there is we'll try a few of those things, and we basically monitor how the filling rates of the reservoirs of Magnetic Island are affected, and then hopefully we can find sort of the sweet spot there where we can just operate that valve with the perfect, you know, I suppose. The trade-off there between lower pressure drops in Pallarenda, but on obviously a lower fill rate over on the island as well. Now, fast forward a little while. So this was probably a while ago now, but just recently, in the last few weeks, what's happening is that we're coming into a drier and hotter time of year now. So irrigation was increasing in Pallarenda, and I was looking at the data, and I could see that we put the valve back into winter setting, for want of a better word. So it was coming on whenever it wanted to. So we were able to actually change that to put a quarantine time in, for want of a better word, where the valve would not open between 5 p.m. and 9 p.m., allowing the maximum available pressure for those irrigation and high use times when residents return home from work, do all their washing, cooking, all those sort of bits and pieces. So look, it can act as an early warning system as well if you know what you're looking at. And yeah, if you're sort of correlating a couple of those operations in there. Again, you can see it's on the owner side, and this one now actually also has an MRC1 installed, so we can actually monitor the water consumption with the pressure, which also gives us a quite interesting picture. So this is what I was just talking about. We could see that, you know, in my hastily marked up little areas, that those dips that don't go down past the sort of 300 kPa are irrigation dips, meaning that this is the times when, you know, the water pressure just drops from use in the area. So now we've quarantined that time, and the complaints have not rolled in as yet, which is what we're after, obviously, to maintain that service level or not of the complaints. Moving on, I'm probably moving a little bit slow, so you can tell me to hurry up a little bit. The Cleveland Bay Purification plant is one of our bigger water treatment plants. We're looking at putting a recycled water treatment plant in there to provide Class A plus recycled water to the community. Now it's currently serviced by quite an old reticulation main that's been in there. We assume somewhere around the 60s, but records going back that far are a little bit hazy. So look, it is time for renewal, and what we're looking at is, well, how big a pipe do we actually need to put in? In order to get that data, we went ahead and we put pressure sensors at the treatment plant. We also retrofitted smart meters onto the main meters of the treatment plant to basically gauge the amount of demand for water and how the pressure fluctuates through in those times to inform the upgrade of the pipe. Look, and basically in the next few months, when we actually start ramping up the installation of the treatment plant, hopefully we'll have a few more results that I'm happy to share with that. Another interesting one is suburbs that are built high. So clearly we've got a little bit of a you know, development assessment code that says you can't build above a certain height, and if you do, you have to put in your own booster pumps. Now, but there is then that little bit of grey area where you're not quite too high to pass to need that booster pump, but you're right at the edge of a serviceable area, I suppose, for water pressures and flow. And what happens is we get plenty of complaints, because what happens, they might just be at that level where we can still supply them with the right pressure at street level, but then they're building 2- and 3-story homes, which then makes it really quite complicated for us to get that pressure up further. Now, our service standard obviously relates to the water pressure and flow at the water meter. But what we also then don't know necessarily is, if we just do static pressure tests, we don't understand the full picture. We don't know how the pressure changes over time. We don't know if it's just that one house. Did the plumber put a 15 mil line up to the house instead of a 20 or 25 mil? So there's all these sort of little problems that we might not know about. So putting in pressure sensors in that area actually gives us a much better understanding. And in this case, again, we're looking at potentially upgrading the reticulation in the whole area. It's a multi-million-dollar project. And what we're trying to avoid that by potentially really honing in on where the problem hotspots are, rather than just taking like a whole street or a whole area from a suburb and trying to then fix the problem there, which might not have a problem. Yeah, so that's a beautiful picture there, Mount Louisa, Pallarenda in the background there as well. And look, I'm sure it's not uncommon around other areas as well, where people like building on hills, people like building up, and it just becomes really challenging to supply the right pressure and flow to those. And again, so one of the solutions, rather than spending a lot of money on a full reticulation infrastructure upgrade, could be to just install some booster pumps in some specific areas. Still not great, still fairly high maintenance and you know, and energy costs, but it still beats a multi-million-dollar project, especially at the moment. We can also do a little bit of leak detection with these pressure sensors, which is interesting. This particular case is we had a large supply main. This was a 600 mil bulk main, actually, which was crossing the river on the riverbank, basically, just below the riverbed, I should say. It got damaged in our large floods in 2019. And if I can find my mouse cursor, you can see the exact time of the break here, pressure drop. And you can see it took us, I believe it was close to 12 days or 10 days, 11 days to actually find where the pipe was broken, so we could actually isolate that piece of infrastructure to restore the pressures. And obviously during all that time, water was fairly leaking out of this large main. If we would have had a few more pressure sensors in the area, potentially we would have been able to shorten this time. If we could have narrowed down the area of pressure drop. So we did that now. We've gone in and we've put a whole lot more pressure sensors around our larger bulk mains to hopefully narrow down and bring down this time of when we can actually find the problem and fix it. This, by the way, that wasn't fixing the problem here. We just isolated that particular piece of pipe. Just recently, we had, and this is another really interesting one for me, is we had a complaint from a contractor basically doing some hydrant flow testing for fire certification at a retirement village. And so we got some investigation complaints to some degree, so a request to investigate the pressures at that site. So we went ahead and we put, it's quite a large complex. It's actually fed from it's got 3 main supplies and 5 water meters. So we fitted smart meters. We fitted 3 pressure sensors on each of the mains. And investigations during that day too found that there was a piece of main isolated out the front of the retirement village where there was a break, just recently a break, and we didn't fix it straight away. There was an issue with main roads. And anyway, long story short, we isolated that piece of main. When this complaint came in, I suppose we fast-tracked the fixing of that issue. And what we found is that actually didn't do much. So this is basically around about here. The line was fixed and the isolation was taken off. So we reset the valves, opened the valves. And you can see that the pressure didn't really increase dramatically and that the pressure's sitting fine here anyway. So this is KPA. So we're sitting at or above 500 KPA throughout the whole time. So this is, it's about 4 or 5 days worth of data. But what we then found is that from the smart metering is that they've got a combined leak around about 600 litres an hour or 8 litres a second, which quite likely is impacting their flow and pressure at various hydrants in the complex. So we could go back to the contractor and I suppose the manager at the retirement villa and said, look, these are the pressure readings. We're supplying you all the pressure we need at the point of supply. And you might have to, investigate some of these leaking issues, which I should have to say, not guaranteed leaks, but potential leaks. Being a large retirement village, it could also be that there is some continuous use, but it seems quite high. So in my opinion, there is something going on internally there that they'll need to rectify. And there's another interesting one. So we get it internally as well. So we get internal pressure complaints from the parks departments for the irrigation systems. So here the issue was that every time the irrigation turned on, the pressure would basically just drop to about 50 kPa. And in their opinion, it was a Townsville water issue where we weren't supplying enough pressure or not enough flow. Look, we put that pressure sensor on and we actually managed to then see that, look, the pressure's fine throughout the whole time, apart from when they opened the irrigation. So further investigation and found again a really large irrigation leak that was causing that massive pressure drop. So these sensors just assist in the management of a whole range of complaints, issues, and just makes it easier. Makes it easier if you can actually show people what's going on, and the whole diurnal patterns of pressure are really valuable. And I think I might have rushed through it a little bit, but it's probably good because I had half an hour, isn't it? So look, there's my dog. You want to be careful where you install these pressure sensors, because that little bastard, he chewed the pressure sensor cable. So he's looking real happy about himself. But anyway, just a little one. They are cable devices, so if the cable comes off, it's not great. Yeah, open for questions.
I'll kick off. Peter Clark from Charters Towers. You've certainly demonstrated that there are some really good outcomes from using these pressure sensors. So how difficult are they to install? Are there any negatives? What problems have you had in using them?
Look, so they're really quite simple. It's a standard 1/2-inch BSP thread. So like I said before, I'll go back a couple of slides so you can see. Oh, a long way. Don't I have any? Oh, okay. Look, they generally fit on the RPZs that we've got in parks. In this particular case, you can see actually I just had to put an adapter in for a 1/4-inch BSP thread. So they literally just screw in, they plug into the LSTT, and the job's done. So I've installed the vast majority of these myself, so it doesn't need a particularly skilled person or a plumber. Unless, of course, you're going into the domestic part, and this is my little dog picture here where you can see that we put, after the meter, again, this is why we put it after the meter, we can just turn the stopcock off, put a little T-piece in. We're using cam lock clamps to put that in. So when we want to remove the device, we can just put a blank in. We don't have to remove the whole plumbing. But in saying that, we've sort of gone away from that a little bit now, because we're thinking that that's not the best thing. If we want to leave it there for a year or two, it has a tendency to be a little bit leaky. So we're going with a fixed T now. And
recording data.
Yep.
How do you get data? How can you use it? Does it download to spreadsheets or?
Yeah. Let me just quickly. So we also subscribe to. Give me 2 seconds. The Aquila platform, which gives us the real. It gives us real-time information for those sensors. Now, I'm not sure, does this work? Can you see this now?
Yep.
Yep. So this is the MyWater platform. The Aquila Sewer platform. I'll get with the program eventually. And you can see, so these are basically real-time sensors. So here's our sensors in Pallarenda. So this is right now. So the last report I had was 3:15. We can go in here and just download the data for whichever time series we'd like. Look, that's not going to open at the right screen now, but so you can sort of, you can go back over the time and assess what's going on. So that's how we're getting the data. Look, I'm sure Taggle's got plenty of other ways to provide you with the data in terms of, depends on what products you're using. Worst case scenario would be a spreadsheet on an FTP, I suppose.
Okay.
I'll go on to Ian, who's put a question in here. Yes, so look, Ian, it's been one of our long bugbears with our IT department. We've been wanting this data to flow into our data warehouse. We've actually got our own local UBU NQ data warehouse built under a local disaster management center. But there seems to be an issue with the ingestion, which is sort of a little bit ongoing, but there's a program underway to feed that into our systems. And then from there, we want to feed it into our SCADA systems as well, to assist in the management there. And yes, we are using flow meters and pressure in tandem where we can, to basically assess that the network health as good as we can. Is there anyone else?
Luke has raised a hand.
Oh, yeah.
Hi, Simon. Luke here. Can you hear me?
Yep.
Simon, that's a really good presentation. Such some great examples. So I've just got a couple of questions. I think you showed it on the earlier slide, but I missed it. What kind of battery life can you expect with these 15-minute measurement intervals that you're doing with these pressure sensors?
So look, we're looking at least 4 years. If I go back into this one here, I'm just trying to think which ones might be some of the oldest ones that we've had installed. Potentially this one. So look, I'm only just over a year with all of these, but in saying that, I've had 5-minute interval ones that have lasted me just over 18 months, 19 months. So yeah, so I'm hoping to get at least 3 years. Honestly, I know Taggle might say 4, but I'm hoping to get 3 out of it. The good thing is that we can replace the battery easily. So it's a D-cell battery that I've changed myself before. So it's not a throwaway item, I suppose.
Yeah, good. Okay. One more question, Simon.
Yep.
So you've showed quite a few examples of these pressure cases. Have you considered any other sort of remote monitoring applications? I know that you do some smart water metering up there. Have you perhaps looked into, say, sewer level monitoring or water quality monitoring, that kind of stuff?
Yeah, we actually do. Let me put everything on here. I had everything turned off a little bit. So we've currently got a few sewer level monitors. We've got a range of them, I suppose. So we've got ultrasonic sewer level sensors that we're using. And we're also using some of the float valves, the ball valves that we just got two in the manhole for a full pipe or a full manhole alert. We're also using an ultrasonic over here, actually as a river level sensor. So this is basically mounted on a bridge to look at a river, to look at the river levels. So look, basically what the idea here is that we can spend roughly about $5,000 with a river, a rainfall and ultrasonic level sensor on a bridge and get more or less the same data as a $50,000 gas bubbler line with a rain gauge. That's the sort of the standard Bureau of Meteorology installation. So yes, we're using a range of different types of sensors through the Taggle network. We've also, obviously, you know, we're trying to complement the SCADA network that we've got all around town as well. So.
Brilliant. Thanks, Simon.
I've got a question from Ian.
Oh, yep. The environmental monitoring is weather stations at this stage. So we've got a couple of weather stations. The Doom Station, it's a little eternal joke. Look, so this is a Vaisala weather station that we're using currently. So we get the, you know, basically the standard temperature, humidity, rainfall, air pressure sort of thing. We're also using standalone rainfall buckets, which these ones actually co-locate. I've hijacked one of the bomb, you know, those big structures where the bomb buckets are on. I sort of clamped one of the table buckets on next to it, sort of thing, to actually correlate how well they work in terms of accuracy. And if I go back to 2019 again, the big floods where we had however many, 2 meters of rain in 10 days or so, the cheaper bucket, when I say cheaper, the bucket that's not using the alert system was off by about 4%. So that's quite good, and it's 1/10 of the price. I'll just wait 2 seconds and then I'll go back onto Luke's follow-up question here. No, it doesn't do any predictions at this stage. So it's very much the real-time monitoring and visualization. So we don't have any predictive algorithms in there as yet. And to be honest, I can't answer if that's on the cards or not. The thing being, to be honest, for us, the the Aqualis sewer platform is just a really good stepping stone for us to really get all this data in and understand the value of it. and then potentially grow with that platform as it develops, or move to another platform. Sorry, Taggle. At some stage, if we can make the case that we want to spend a lot more money for these platforms that are more predictive, and but what we're really wanting to do is collate all this data in a central warehouse and push it to a range of different programs, because there is not one program that fits all. Anyone else?
I think we're done.
All right, excellent. Look, obviously I'm available for other questions, emails or whatever down the track as well if you wanted to. Not a problem. Always happy to share and talk. I can chew you the ear off for quite a while if you're keen. So thanks very much for paying attention and being around and listening to me warble on, and hopefully I made a bit of sense.
Thanks for joining us, Simon.
No
Thanks,
worries.
Simon.
Thanks,
Yes,
Simon.
Simon. Cheers.